Hello, seniors. This lesson is about one-sided limits and why are they very important in finding limits of conditional functions. First, let's recall the two important theorems here regarding one-sided limits. First, if the left-hand limit of f of x is equal to the right-hand limit of f of x and they both approach the same value L, then the limit of the function as x approaches a is equal to L. And on the other hand, if the left-hand limit is not equal to the right-hand limit, then the limit of f of x as x approaches a does not exist. Let's have an example. Let's have this first. What is the limit of h of x as x approaches -1 from the right? So -1 from the right means you're approaching values -1 from its right side. But it's simply in this condition less than 0 because -1 is less than 0. So any values approaching -1 from the right is also in this condition. So we will use this condition. And since we can substitute -1, just substitute -1. So you have -1 plus 2, that will be 1, squared is 1, minus 4, we have -3, over x is -1, so -1, then the limit is simply equal to 3. Next, let's have this. What's the limit of h of x as x approaches 2 from the right? So 2 from the right is values approaching 2 from right side, and they are all here in this condition greater than 1. And again, we can substitute 2, so just substitute 1 minus 4 times 2 is 8, and then the absolute value of 1 minus 8, that's -7. The absolute value is 7 over 2, so the limit is simply 7 halves. Then next, what is the limit of h of x as x approaches 1? Now we know that 1 is critical to the condition. It's here, it is in the function, in the critical to the condition. So we need to get the limit as x approaches 1 from the left, as well as the limit as x approaches 1 from the right. So it is implied that we get the left hand and the right hand limit if we approach a value that is critical to the condition. Now, approaching 1 from the left means values left of 1 or values less than 1. So we should use the second condition, x cubed minus 1 over x squared minus 1. But we cannot substitute 1 right away, therefore we need to do some manipulations first. But x cubed minus 1 we know is the difference of 2 cubes, so it's x minus 1 times x squared plus x plus 1 all over the difference of 2 squares, which is x minus 1 times x plus 1. This cancels out. Now we can substitute 1. So 1 squared plus 1 is 3. 1 plus 1 is 2. So the limit, left hand limit, is equal to 3 halves. Now let's have the right hand limit approaching 1 from the right side. So if we are approaching 1 from the right side, we are values right of 1, meaning we should use this third condition, greater than 1. So we can substitute 1, so it's simply 1 minus 4 times 1, that will be -3. Absolute value of that is 3 over 2. Now, see that the left hand and the right hand are approaching the same value and they are equal, therefore the limit of h of x as x approaches 1 is 3 halves. And let's have the last example. X approaches 0. Limit of h of x as x approaches 0. Again, we know that 0 is in the condition, it's part of the condition there. So we should get the left hand and the right hand limits. So what is the limit as x approaches 0 from the left? So we should use the first condition because 0 from the left are values less than 0. And we cannot substitute 0 right away, therefore we need to do some manipulations, and that will be the limit. That will be simply expanding the numerator. So expanding the numerator, you get x squared plus 4x plus 4 minus 4 all over x. 4 minus 4 will cancel out, and that will leave you with x squared plus 4x in the numerator, which you can factor. The common factor, of course, is x. So that will leave x plus 4 as the other factor, then over x. Now x cancels out. Now we can substitute 0. So 0 plus 4, the limit is 4. So the left hand limit, or x approaches 0 from the left, is 4. Now, what about the right hand limit? X approaches 0 from the right. So if we approach 0 from the right, then we should use the second condition. And we can simply substitute 0. 0 minus 0 cubed minus 1 is negative 1. 0 squared minus 1, also negative 1. So negative 1 over negative 1, this is positive 1. Now, the left hand limit is not equal to the right hand limit. Therefore, we say the limit simply does not exist. The limit as x approaches 0 does not exist. Clear? Now we go to my favorite part again. But this time, let me help you. Let's do it together. So since the function is very easy, let's do it together. So we have limit h of x as x approaches 0 from the right. Then which condition should we use? 0 from the right should be the first condition, and then we can substitute 0 times 2 minus 1. So the limit would be negative 1. Next, x approaches 4 from the left. Where is 4 from the left? The condition that will satisfy that is, of course, the third condition, and then we can substitute 3 times 4 plus 1. That will be 13. That should be 13. That should be 13. There. Next, x approaches 1. 1 is in the first condition. So 1, although that you're approaching 1 not specifying from which side to approach it, from either from the left or from the right, but it's clear that it is in the first condition. So you can simply use the first, and substituting 1 will give us 2 times 1, 1 minus 1, which is 1. Okay, now what is the limit of h of x as x approaches 2? 2 is part of the condition again. So it's critical to the condition. So that's why it's necessary to evaluate both the left hand and the right hand. There. So what is the limit as x approaches 2 from the left? So we should use this. Then substituting 2, 2 times 2, 4 minus 1, that's 3. Now limit as x approaches 2 from the right. So 2 from the right would be the second condition, and then just substitute 2 squared minus 2 plus 1. What's that? 4 minus 2, 2 plus 1, that will be also 3. The left hand equals the right hand, therefore what's this? Yes, you know it, it's equal to 3. Okay, last example. X approaches 3, and again, 3 is part of the condition, critical to the condition there. Therefore, we should again evaluate the left and the right. So what is the limit as x approaches 3 from the left? Using the second condition, because 3 from the left would be less than 3. Now substituting 3, 3 squared, 9 minus 3, 6 plus 1, that's 7. 3 from the right. So x approaches 3 from the right would be obviously the third condition. So it's 3 times 3, 9 plus 1, this is 10. Now again, the left hand, the right hand, if they do not approach the same value, we say that the limit as x approaches 3 does not exist. Okay, if you have any questions, again, you know where to find me at room 508. And if I'm not there, I'm probably at the 4th floor walking around. Good day.